Okay, this will definitely be the last podcast of this section. So let's recap the magic school bus and the solar system with a few words that we must all know after going through this section. What are the words to know? Atmosphere, the mixture of gases that surrounds the planet. Right? I think you already know it. Atom, the tiniest part of a material that has all the properties of that element. All matters in the universe are made up of atoms. Should I say all matters? All matter in the universe is made up of atoms. For the longest time we thought that's the smallest unit of an element, but obviously we now know that atom is made up of subatomic particles, which themselves are made up of many more things, but we will not worry about it. Probably you learned about it somewhere. Comets, we didn't talk about it here, but a small snow and dust space body that travels around the sun. Some get near the sun and develop two long tails. It's always fun to observe comets, and there have been some famous ones, and there are a lot of superstitions associated around comets when they become visible for us as well. But there are now space missions that have been sent to comets to recover material from them and come back, so that we know their origin, their composition, and so on and so forth. Core, the most inner part of the planet, of any planet. On Earth, the core is the intensely hot, most inner part of the planet. There are details. There is an inner core, there's an outer core, and so on and so forth. We didn't talk about it much. Eclipse, the effect achieved when one space body blocks the light of another. We talked about moon getting in between Earth and sun. So in an eclipse of the moon, the Earth is directly between the sun and the moon. In an eclipse of the sun, the moon is directly between the sun and the Earth and blocks sunlight. Okay, so in an eclipse of the moon, sun is here, moon is here, and Earth is in the middle. And in an eclipse of the sun is here, moon is here, and Earth is here. Okay, so just make sure. Gas is a substance such as air that will spread to fill any space that contains it. So think of a solid. If I take a cup and put let's say a chalk in it, it just sits there. If I put water, it's going to occupy the entire cup. But if there are little gaps, liquid may not necessarily get in it, but gas is much more able to fill the spaces. Gravity, the force that pulls one object toward the center of another object, keeps it from floating away. So sun exerts gravitational pull on Earth, any object that has mass. So Earth pulls the moon, moon pulls the Earth. What does it mean for us? Climate. The gravitational pull by the moon actually creates tides on Earth. As you know, there are tides, high tides, low tides, mixed tides, and so on. And tidal cycles, full moon, new moon, waning and waxing gibbous, and so on, create variations in tides. And there are lots of stories about how lunar cycles can create people to go mad and so on and so forth. But tides are moving the atmosphere and the ocean constantly, which means that that movement of the ocean, atmosphere, air moving around is not always very obvious, but when the tides come on the coast, you know that when there is high tide, you have dramatic splashing of water. There are many places where you can go to watch the splashing tides, and Venice, for example, completely gets flooded when there are certain wind directions and high tide coming together, and so on and so forth. So it turns out that tides have a very important role to play in mixing up the water and hence heat in the ocean, which means it's very important for climate as well. So moon has a big role to play as well. Okay, so magma, as we said before, melted rock found beneath the Earth's surface. It is called lava when it flows out of volcanoes. We'll talk about volcanic impact on climate a little bit later, but you already know that when volcanoes go off, there is a lot of dust and chemicals thrown into the atmosphere, very high sometimes. That can block the sunlight, which means energy coming in is reduced, which means we can cool the climate. And it has happened in the past where large volcanic eruptions have created climate to be cooler than normal. There is a year without summer in 1816, so you can go and find year without summer, which volcano it was, where it was, and what actually happened when it went off and created this year without summer. Has lots of impacts on rainfall distribution, on agriculture, on people, and if you really want to look for it, try to find a painting, a famous painting that relates to volcanic eruption as well. Okay? So orbit, the curved path followed by a moon, planet or satellite as it circles another large space object because it's gravitationally trapped to that larger object. Radar is a way to find solid objects by reflecting radio waves off them and receiving the reflected waves back. Radar is short for radio detection and ranging. So I said it wrong before. Radio detection and ranging. Okay. Rotate, to move in a circle around a central point like a wheel. Satellite, a moon or another space body that travels in an orbit around a larger space body. So now we are launching satellites from Earth to rotate around the Earth or around another planet, or go out of the solar system, and so on and so forth. Okay, so this definitely concludes this section on weather, climate, energy balance, solar system, orbital parameters, how weather, climate, and sun's energy change over time, and the key words that we used along the way. We still have to do greenhouse effect, which is what we will do next, and we'll look at a little bit of chemistry of which molecules in the atmosphere are able to allow sun's shortwave energy to come in but act as a blanket trapping the outgoing thermal energy, long wave energy, infrared energy, and so on. Okay, so again, I'm taking time with each infographic or a slide in the PowerPoint because I need to explain it properly. In a class in college, I would have finished this whole lecture in 1 hour. Okay, so here we have 9 podcasts, which is longer than 2 hours, but that's okay. We are not in a hurry to finish these, right? So the trucks going by, I hope the sound is okay. I will check and make sure. Okay, see you in the next section on greenhouse effect. Exciting, right? Bye bye.